Good afternoon. Hello, everyone. My name is Ghasem Sharifi. And during this presentation, I want to short talk about my thesis. That is, the title is Mission Operation Control of ETPAC project. My supervisor is Professor Gonzalo Sanchez and Andres Marcos. First, a brief introduction about space debris. We are observing that the number of debris and junk is increasing dramatically, and already we have about tons debris and junk in the Earth, rotating around the Earth in the low orbits. And also among from them is 3,000 inactive satellites. And because of this amount of debris, the new policy has been made in order to have a sustainable space for the future mission and satellite. And this policy is that for the future mission and satellite, the lifetime of all of the satellite in the low orbit should be lower than 5 years. That this time was previously 25 years. And because of this new policy, there are many different mechanisms and technology and idea in order to deorbiting the satellite. That one of them is ETPAC, that we are working on that. And what is the ETPAC? ETPAC is a satellite. It's including two modules. One of them 8U and another is 4U, CubeSat size satellite. And during the satellite missions, in a specific time, it's separated these two modules from each other. And between these two modules, we have 500 meters tether. The altitude of the satellite is 600 kilometers, and the inclination is 50 degrees. And the launch date should be 2025. About the operational mode that we already considered, first the satellite is going to the lobe, that is the first operational mode, and after that we are going to the commissioning, that is a communication with the ground station and the satellite in order to ensure that every subsystem, every device is working properly after the launch. And after that we have a nadir pointing, we have a deployment, two modules separated from each other, and after that we are entering the science mode. And you can see here in the picture, the orange line, we are seeing that after the deployment, if we don't have any tether works, first I should say that the nominal time of this satellite, if we don't have any tether, it will be more than 5 years. And if we have a tether without any working the tether, only because of the drag, the deorbiting time less than 6 months. And if tether works, we have a Lorentz force, this deorbiting time decreased to 2.5 months. About the satellite operational control, that my thesis is concerning about that. There are different important tasks that we should do. The first one is that we should provide a reliable communication between the satellite and ground station in order to monitoring the satellite system, sending telemetry and housekeeping data to the ground station, and also we should provide some command in order to changing the different mode, updating the parameters on the satellite as an uplink command. Another thing, because we are in a deorbiting time, we should have a prediction for the life of the satellite thanks to the BESMA software. That is a very high accurate software in order to modeling the tether operations and also a space environment. We can have a prediction for the satellite life. Another thing, that if we have a satellite, we have a mission planning and scheduling. We should sending some command in a specific time in order to controlling satellite in the space. And another important is the fault detection and isolation that we have in ground station. We can, because we are getting all of the housekeeping data from different sensors, we can detect fault and some anomalies in different subsystems and taking action based on this data. Furthermore, is about the monitoring tether dynamic and control. We have two modules that is 500 meters separated from each other, and also we have the Lorentz force and gravity gradient torque. These two, they are fighting to each other, and because of this, we are increasing the energy rate. So the tether is not always vertical in the orbital plane, and we have some in-plane and out-plane angle. So we should have some controlling for preventing the instability. So we need the information from both satellite and the ground station. So one of the task of this operation control also is the control of the dynamic of tether. After that, how we can have this operation control? We have a ground station that getting the data from the satellite. Already we consider two ground stations, one of the primary and secondary. Primary is the reliable ground station network that has lots of ground station different places of the earth. This is the primary, and also we have a backup in the UC3M that we are designing a ground station in UC3M. All of this data are going to the mission controller center, that all of the activity that in the previous slide I mentioned will done. And also we have an interaction between the BESMA software, that's the high accurate modeling of the turtle. About the UC3M ground station, already we have a diagram and a sketch of this ground station. It's divided to two parts, outdoor and indoor. In the indoor, we have a transceiver, we have a mission controller, we have a rotor controller, and the outdoor, we have a antenna and the rotor. Already we purchased some of this equipment, transceiver and mission controller already purchased. And for communicating to the satellite, we already calculating the link budget, the pointing loss, every antenna and other equipment that we need for completing this ground station already is finalized. So maybe during the next month, we will finish designing this ground station. Thank you so much. If you have any question.